Welcome, everyone. Well, today I have a great guest, Lucy Biven, Biven. She wrote a fascinating book, which I'll tell you about, and right now called The Archaeology of Mind, Neuroevolutionary Origins of Human Emotions. Lucy Biven trained at the Anna Freud Center in London and has served as head of the Department of Child and Adolescent Psychotherapy at the Leicester National Health Service in England. And she's also got a great book coming out in a few months. We're going to talk a little bit about it, just kind of whet your appetite. It's called Shortcut to Understanding Affective Neuroscience. So let's find out where all these emotional stuff came from. Before we do that, if you want to support our podcast, make sure to share and subscribe. Welcome, Ms. Biven. How are you? Doing very well. Thank you for being here.
I can't hear.
So welcome, Ms. Biven. Thank you so much for being here.
Oh, it's my pleasure. Thanks for inviting me.
So tell us a little bit about the Archaeology of Mind.
I can't hear you. Oh, The Archaeology of the Mind is a book that I wrote with Jaak Panksepp. And by that, I mean, I very much wrote it with him, me being the addendum. I got to know Jaak's work a long time ago. And he said that he wanted to write a popular book. Well, to be honest, we never did write it, but I offered to help him with it, and that's how we got going. It isn't really a popular book. It's more an update and a rendition of his first book, which was about affective neuroscience, which was the book that absolutely just thrilled and enchanted me. I thought it was fantastic. He's the one who invented the whole field that he called affective neuroscience, which is to say, the way that the brain creates feelings. And his work is just groundbreaking. He was marvelous.
Yeah, it really was. It was definitely groundbreaking. Let me ask you this. Does the book now, a few years back, it covers brain structures and emotions. Does it also cover functional connectivity?
Oh, absolutely, yes. One of the things that Jaak delineates is 7 basic emotional systems found in the brain. Let's see if I can remember them all. There's rage, fear, grief, which is fear of isolation. There's lust, of course, self-explanatory. There's the seeking system, which is enthused curiosity, a sense of personal empowerment, a sense of agency. It's quite euphoric, and also the care system typified by maternal nurturance. I think I said 7. I hope I did. But what he does, but he delineates where in the brain these 7 systems are found, the chemicals that fuel them, and so on. He's more successful with some systems than he is with others, which is to say the research is more conclusive, and probably there are more systems to be found. Most notably, probably there's a system for disgust, and probably there is a system for social dominance, although it hasn't been found yet. And so that probably lies in the future. But certainly the taxonomy that he provides is superior to anything that's available today, because it's rooted in brain science. It's not like you look at the way people talk and the way they behave and you just try and figure it out. This is hard science. So it's much better.
That's amazing stuff, because you kind of reminded me a little bit of Paul Ekman in the 7 Universal Expressions there.
Well, in fact, the fact that Ekman's taxonomy includes disgust and social dominance has led people to believe that Jaak Panksepp's taxonomy is probably not complete. Some people say there's going to be more circuits that are found. Some people say, no, maybe it's a combination of various circuits that we already know about. I don't know. I don't have any opinion about it. I don't know how it's going to pan out. But it's probably not complete, but it's really good.
It's amazing stuff.
It's really good.
How do you think it helps in the world of psychotherapy? How does it help understand the human being better?
Well, first of all, there's a much wider range than psychoanalytic theories. Psychoanalytic theories, it's basically uh, sexuality, aggression, the need for attachment, uh, the need for one's worth to be validated, other ones as well. But this one's much wider. And as I say, it's rooted in brain science. But when you ask, how does it help? I'll just give you a couple of examples. For example, there's two different kinds of anxiety. One comes from the fear system, which is typified fear.
I'm sorry, Ms. Biven, we're having some kind of technical issues there, but you were talking about two fears, or two systems of fear and anxiety?
Yeah, there's two types of fears, two different types of fears. I said one that emanates from the fear system. The fear system is basically the fear of death, the fear of injury. It's physical, usually physical bad things, but it can be anything. You can be afraid of a tax audit. You can be afraid of a final exam. You could be afraid of your boyfriend breaking up with you. You can be afraid of anything. And the other kind of fear is the kind of anxiety that you see in children who are lost, like in a supermarket. Do you ever hear that scream of terror when a child can't find his or her mother? That comes from a different system. And the way we know is that they respond to different medications. For example, the fear system responds to benzodiazepines, things like Valium. That'll make you feel better. If you're scared, let's say if you're about to, excuse me, if you're about to have surgery and you're afraid of the thing, going under the knife, you take a few Valium, you will feel better. It'll make you feel better. But if it's, let's say, you're feeling extremely lonely, also panic attacks, they think probably this comes from the grief system, the fear of social isolation, the fear of being left all alone, that you're betrayed, you're defeated, you're abandoned, something like that. It's typified in young children, and of course you can see how adaptive it is. If a child's left alone and screams, the mother finds it, and it protects the child. So it's very important for the child's survival. Now that kind of thing, which is also the root of well, I'll get onto that later. I'm sorry. I've jumped the gun a little bit. That is assuaged by medications like imipramine, antidepressants, things like that. Imipramine doesn't have much effect on the fear system. So if you're afraid of surgery and you take imipramine, it's not going to help you. And at the same time, if you're lonely and miserable and you take benzodiazepines, I don't know, it might make you feel better. You're a little high, but and the antidepressant would be much better. Now, so those are two kinds of fear, and it's important to distinguish them because they have different etiologies and they come from different places. For example, someone who suffers from anxiety, being left alone, and is always afraid of, tremendous separation anxiety, panics that way, you're going to look for an attachment disorder. Whereas somebody who's just very physically afraid of anything bad that might happen and is extremely cautious, then you will see that they probably had an experience that made them very frightened at one time in their life. Now, the other way, two things is there's two kinds of depression, and there's two ways to feel good. And one kind of depression, again, is part of the grief system. In other words, when you're not panicky about people who've left you, but you just feel, this isn't going to work out. I'm going to be alone. Nobody's going to like me. Nobody's going to care about me. You get depressed. You get miserable. And on the opposite side of that, this grief system sort of has two sides. The one side is the miserable side when you feel miserable and abandoned and so on. The positive side is when you're in the company of people who love you, people who support you, people who take care of you, people who are on your side, and then it's a wonderful feeling. So that's the way that the grief system can make you feel either bad or good.
Oh, wow.
And the other one is what I was talking about a little bit before, the seeking system, which engenders a sense of euphoria, enthusiasm, anticipation. Just think about you're about to go out on a great date. You're about to see a fantastic show. Tonight you're going to see Hamilton. You've been dying to see it, and you're just rubbing your hands. You're so enthused about it. Now, obviously, when that system is aroused and it's fueled, then you feel great and you feel like, oh, I can do anything, and I'm going to do this, or I can sort of conquer the world. It's that kind of good feeling. When it's on a low ebb, very hopeless, not the kind of gnawing misery of, oh, nobody loves me, but just the sort of, oh, what is the point? What's the point of anything? And the grief system is mediated by opioids, which is brain chemicals like heroin and morphine. Little bits of them make you feel great, make you feel fantastic. A dearth of it makes you feel miserable. The seeking system, that enthusiasm for the world and the sense I can take risks, I can do anything, that's dopamine. Now, one of the reasons why people take methamphetamines and cocaine and drugs like that is that it prolongs the activity of dopamine, and it makes you feel all hyped up. And when people take those things, they're just very enthusiastic. They're hyper. And it also engenders certain kinds of obsessive behaviors. That's a sort of pathological end of it. But they take it because they love that feeling. They love that feeling of being so enthused.
And there got a lot of questions for you now.
Oh, yeah. Okay.
What are the brain? Now you mentioned two different fear systems. Are we looking at two different brain structures as well?
Oh, yes. Yes.
And which are they? Yeah. I'm assuming the amygdala is playing a role somewhere around here.
Yeah, the amygdala plays the role in the fear system, which is fear of death, fear of bad things happening. It's basically the amygdala. It's in hierarchical order. Top is the amygdala, and portions of the hypothalamus, and then portions of the periaqueductal gray, which is in the brainstem.
Wow.
The periaqueductal gray is involved in all emotional systems, or parts of it, and the grief system, geez, I can't remember the details of it. I'm sorry. You want to know about the substrates of the grief impulse?
Yes, if you could tell us a little bit about the brain structures of where the grief system works.
Well, again, as I said, the periaqueductal gray is involved in all the emotional systems. So it begins there. It moves on to the dorsal medial thalamus. There's septal areas. There's the bed nucleus of the stria terminalis, which is really just an offshoot of the amygdala, and scattered sites in the hypothalamus and amygdala. But the main thing that's different is that it's fueled by mainly by endogenous opioids. In other words, endogenous opioids make you feel really good. A dearth of them make you feel bad. For example, in post-mortem examinations of people who committed suicide, there's low opioid activity, lower opioid receptors, that sort of thing. Also, you find this in people who are drug addicts, who are typically unhappy, people. You'll find that as well.
I guess that now I have to do a timeline in my head. So now that we've identified the structures, or you folks have identified the structures and these different systems of affect, how is it influencing the developmental concept? In other words, are these being developed this way because of trauma in childhood, things of that nature? Are they starting to have, like you mentioned a minute ago now, for individuals who have low amounts of opioid and the suicide correlation there? Is that something that we can see from trauma, we can see from child abuse, we can see from some kind of complicated birth, anything of that nature?
Well, it's mostly animal studies that they've done. For example, if you take a rat and you isolate it, for, I don't know exactly the period of time, but isolate it from its mother, what you'll find is that it has fewer opioid receptors in its brain. It's much more prone to being anxious. It's much more, it doesn't really function that well socially as an adult. But it remains just kind of anxious, I don't know, unhappy as a rat gets. throughout its life. Now, looking at the other sort of fear, which is fear of death, fear of injury, if you subject a rat over a period of time to a cat, so in other words, you scare the bejesus out of this poor rat, what you find is that there's much more circuitry, long-term circuitry, what they call LTP type circuitry, long-term potentiation type circuitry, stable pathways that are created within the fear areas of the periaqueductal gray and within the pathways of the fear system itself. So, and those animals remain unusually fearful for the rest of their lives.
Wow. Well, I guess that explains Tom and Jerry pretty well.
Yeah. But you know, when you want to talk about the cure that psychotherapy provides, when you have something like that, where a particular emotional system has been adversely sensitized to the point where there's neural pathways there, you can't get rid of them. I'll tell you why. I'll give you an experiment that explains that. Joseph Ledoux, I don't know if you've heard of him. He's a brilliant guy, absolutely.
Oh, yes. We interviewed him a month ago.
Oh, did you?
Yes.
Did you? Yeah, he's fabulous.
He's amazing.
Anyway, yeah, out of this world. Anyway, he was the one who first discovered the amygdala as essential for fear conditioning. Now, if you fear condition a rat, and so let's say you give it a shock to its foot and you play a tone, at the same time, that rat will remain afraid of that tone for the rest of its life. You can extinguish the fear response if you play the tone over and over and over and over and over, and you don't administer any shock. After a while, the rat it doesn't respond with fear. Now, if you suddenly expose a rat to an unexpected shock to the foot, or let's say you put the rat back in the cage where it was conditioned, a different cage than its usual one, or let's say it's exposed to the researcher who conditioned it. It can come back. Suddenly you play the tone and the rat freaks out. Oh, and wow. That'll happen. Now, what does that show you? What it shows you is that the original fear circuitry does not disappear, because otherwise the rat wouldn't become afraid again. What happens is you have circuitry that you build up over time that suppresses the fear circuitry, in other words, inhibits it, and they're in competition with each other, and the suppressing circuitry usually wins, but under periods of stress, the original problems can come out. And that tells you why psychotherapy is never complete, because you never get rid of original things. You help people to cope better, in other words, to create adaptive circuitry, if you like, to make their lives better, but we're never completely cured. None of us is. But there is one slightly silver shining in the lining there, which is to say, let's say you condition a rat and you do the tone shock thing, and then immediately after you play the tone over and over and over and over again. The rat, it's very difficult to get the rat to stop being afraid of the tone. If you wait a few days and then try it, the results are a lot better. Now, what does that tell you? That tells you that some of the conditioning circuitry, the circuitry that makes the rat afraid of the tone, deteriorates over time. So that helps. That's one of the reasons why they say time is a healer, because there's a certain amount of deterioration, but it isn't complete. And now on the not so good side, you can condition a rat by pairing a shock with a tone. 1 time, 2 times, that's all you need. That's all you need. To extinguish that fear response, you need to play that tone over and over and over and over, many, many times. So it's much more difficult to extinguish than it is to create.
That brings me to
Easier to break.
That brings me to 2 more questions for you. First one, back a little bit to the rat here, Jerry. When we see this, so we condition them to be afraid of the tone, then you suppress the tone or the fear. If I was to say before the suppression component, before we did the psychotherapy, for instance, the valence was at a 9 out of 10 that he was afraid of the tone.
Yeah.
When you suppress it and it comes back, when later on we try it again and all of a sudden it reactivates it, is it a 9 again, or is it now about a 7 or a 6? Do we know that?
No, I don't think there's an answer to that one. Or they, with animals, you can't ask them. So all you can say is that all you can say is you get the physiological manifestations, which is to say the rat freezes or runs away, fear behavior.
Yeah, I just wonder if he froze a little less, if he ran a little bit less further away. I'm curious to see how he responded.
No, I see what you're saying. No, that's an interesting question, and I'm sorry to say I don't have the answer to it. It until you said it just now, it's never even occurred to me.
Well, yeah, I wonder what that is.
I think it would probably depend on the degree of the stress that the rat was under. In other words, if you gave it a shock to the foot suddenly, just out of the blue, I would guess that the rat would respond a lot more strongly than if, let's say, you just put it in its cage, the cage where it was conditioned. I would guess that there's probably no clear way to discern it. You'd have to run a lot of experiments on the level of stress that the animal was under, and then measured its behaviors.
Interesting. It's funny because I had an interview with Dr. Hellerstein from Columbia University, and he's doing research on psilocybin. And he exactly the same things you had mentioned. He was saying a lot of times we have this circuitry, and it kind of works like a broken record. It just gets stuck on this thing. It doesn't let go. For people like depression or anxiety and things of that nature that just kind of keep going.
But it's probably all those thoughts and everything, those ruminating thoughts and so on that just go round and round like a broken record. Those are fueled by a sensitized system, a sensitized emotional system, because the emotional systems arouse a general rule of brain science is that emotional systems arouse the cortex, the thinking brain, and the cortex inhibits the emotional systems. It's not a hard and fast rule. I mean, you could tell somebody a ghost story, which is to say you're telling them a story to their cortex and you can scare them to death. So it doesn't always work that way. But one of the things that one of the sort of depressing things, I don't know if Ledoux mentioned this to you, but it's in his books and in his articles, is that when you're talking about fear, there's many more neural pathways leading up from the amygdala to the cortex than there are in the other direction, which means the amygdala has a tremendous amount of power to enervate and arouse the cortex with all kinds of frightening thoughts. Then the cortex has the ability to inhibit the amygdala, which is to say, another general rule is that when emotions are aroused enough, they always win. They always.
Yeah, that was a disappointing part of the conversation.
If a lion is coming towards you with bared teeth and claws, and somebody was to say to you, well, getting killed isn't the worst thing or something, nobody could talk you down. Nobody could talk you down. And there's good reasons for that. It's just that when those things become pathological, in other words, when somebody is frightened of something they don't need to be frightened of or they shouldn't be frightened of, that's when you're talking about psychopathology.
Interesting. Fascinating discussion. So I know, okay, so we've talked about that. We kind of covered the area of the development. We kind of looked at the amygdala and trauma in a sense. It seems to be having an effect here as well. How about in the world of depression? What do we see here in brain structures?
It's the grief system, generally. Depression, as I said, the grief system or the seeking system. It's either the grief system, which is to say, if you've had, bad parenting, you've been subject to lack of care, betrayal, things like that, you will, it will sensitize the fear system. I mean, I've had, depression is a very common complaint. It's a very common presenting symptom. And excuse me, I'm in Washington, D.C., and it's allergy season, and it's killing me.
Yeah, I've had several clients like that.
Yeah, no, this is one of the worst areas of the world. But
oh, really? Oh, wow.
Yeah, it is. Yeah, it is. But what was I saying? Oh, yeah.
Grief system and depression.
Yeah, when chances are, from what we understand, those systems are probably sensitized, probably to some extent permanently. If you have a patient or somebody who's been seriously depressed, they've looked at it statistically. The chances of them becoming depressed again at some stage in their life doesn't mean they won't get over it, but it's pretty high for these reasons. And I think probably everybody's been a little bit depressed sometimes. I mean, I don't know anybody who's never felt depressed. I don't know anything like that. It also, there's been less research about it, but it can also occur with the seeking system. I remember seeing sometimes in very dysfunctional families, that actual curiosity or interest on the part of the children was actually discouraged. Usually parents who were themselves a bit depressed, and they wanted those children just to remain very dependent and close to them. And I remember there was one time there was a little boy, could have been more than 4, and I wasn't seeing the family, but somebody else was, and he happened to just wander out into the hallway, and I encountered him, and I was just chatting with him a little bit, and his father came along right away and just shoved a bottle in his mouth and sort of said, "Don't interact with that lady. Don't get interested in anything. Don't let anything enthuse you. Get back to your bottle. Regress, please."
Oh,
and,
wow.
And yeah, you see that sometimes.
You made a great point earlier. A lot of people don't realize, especially in society where a lot of people have this kind of dichotomous thinking, as cognitive behavioral therapy would talk about. And you mentioned how we can never fully heal anything, because you explained it neuroscientifically as well. And I think a lot of people don't realize that. They don't realize that everything's on a continuum, especially in the world of psychology.
Yes, I think that I read a few papers. Quite a number of psychoanalysts have known this for a long time, although some, I think, flatter themselves that maybe they can do better than they can. I mean, yeah. If somebody comes to you and they're in bad shape, and you help them so that they get on with their life and they feel better, you've done your job. You've done well. That's and they should be glad for what they got. You can't turn anyone into some sort of shining, paragon. Since none of us are, it would be a mean feat.
Any of my students are out there listening, this is great advice, because it's true.
Yeah.
Well, Ms. Biven, it was such a pleasure. Thank you so much for doing this. Before we go, I wanted to see if you can tell us about a minute or two about your new book coming out in a few months, Shortcut to Understanding Affective Neuroscience.
Okay. I started writing the book for myself because I was confused. There's a number of different hypotheses about how the brain creates affects. Neuroscientists usually distinguish between emotion and affect. Emotion is purely the physiological stuff. In other words, this system gets activated, and then you get these manifestations, usually stereotypical, like your fear system is activated, you freeze, you run away, things like that. Your stomach churns, your hair stands on end, your pupils dilate, all that kind of stuff. Affects, on the other hand, are private experiences that you cannot directly observe in other people. So the question is, there were a number of different hypotheses about which parts of the brain create affects and sort of what they are. And I go through them. There's 3 basic ones. There's one, it's funny, it's Joseph Ledoux, brilliant as he is, he espouses one which I think is wrong. There's another one that Jaak Panksepp espouses, which I think is right, which is to say affects emanate basically in the brainstem. Contrary to popular opinion, the amygdala is not the source of all emotion. It's the periaqueductal gray in the brainstem that probably is. And then there's a new one. It's called the conceptual act theory, the one by Lisa Feldman Barrett. I don't know if you know about it.
No, I know we're interviewing her in a few months. So tell me about this one.
It's quite circuitous. Basically, what it says is that when you have an experience or when you come upon a particular stimulus, your body undergoes a kind of a reaction. It feels either good or bad. There's a certain level of arousal, but it doesn't mean anything to you. You don't know what it is. You hardly notice it most of the time. It's only when you have a concept about what it might be. And she uses the example. She said, suppose your stomach starts to churn and you're in a bakery shop. Well, you have a concept that cakes satisfy hunger and they smell good and everything. So you might interpret your stomach upset as hunger. But if you are out and about in flu season, you know about flu symptoms, you just say it was nausea. Or if you were in a doctor's office awaiting a diagnosis, you would interpret it as anxiety because you have concepts about that. And I think she's got it all wrong. And I go through it quite exhaustively. Actually, it was a hell of a lot of work because she's very thorough. And so it took a lot to go through it, but
and then I constructivistic look at it.
Oh yes, it's a conceptual act. In other words, you feel anything because you have a concept that you got on the basis of your experience with other people and other interactions. So I think it's wrong, but and I delineate that. I explain that in my book as well as I can, and then I give a what can you say? Make a case. I make a case for the brainstem school, which is basically goes like this: the seeking system, which is to say enthused anticipation about things, typically occurs when people are in a state of homeostatic imbalance. It's very adaptive because when an animal is hungry, what should it do? It should go out and look for food. It should be enthusiastic. It should do it with purpose. If you deactivate the seeking system, in other words, put a damp on dopamine so that the system isn't functioning, very difficult to keep an animal alive. You can have an animal there and its very favorite food right next to it, the animal won't bother to eat it. So, but when you say that, basically when you say that this enthused affect doesn't stem from homeostasis, and then you look at some other options as well, which I won't bother you with, it isn't any of those. So it has to be an affective reward. It has to be something that makes you feel good affectively, as opposed to being a homeostatic reward or being a material reward of any kind. I'll give you an example.
Wow.
You take an animal and once a day you feed it, and at the same time that you feed it, you give it the opportunity to electrically stimulate its seeking system by pressing a lever, let's say. It'll go for the system, won't go for the food. In other words, it's a non-homeostatic reward that is even superior. That's what happens. So it's on that basis that you can, I can't do it in just a couple of minutes, but it's on that basis that that's the basis on which I make a case for the brainstem school. And then I talk about a couple of brainstem theorists, Damasio and Antonio Damasio and Jaak Panksepp, and their different theories, and it's sort of interesting because what happened as a result, an unexpected result. All I wanted to do was to explain these different theories about how the brain makes affects, make a figure out which one was right if I could, which I sort of did, and then explain, just expound a bit on, brainstem theories. But in examining Damasio's theory, Damasio has an idea that his idea is that all affect is a reflection of homeostasis. In other words, when homeostasis is out of balance, you feel bad. And that's true an awful lot of the time. But he also says that all emotional behaviors, like running away or running toward or embracing or, kissing somebody or smacking them or whatever it is you do, that this rebalances homeostasis. For example, if a bee is flying around my head and I don't like bees, I run away. And that way I get rid of the bee and I feel better. But it's not always true, because sometimes we take risks. That's a manifestation of the seeking system. Take a risk in order to achieve something. In business, think about the Wright brothers. The Wright brothers risked their lives all the time, and they never thought of giving it up, because they were powered by the seeking system, but that behavior did not enhance homeostasis. In fact, one of the brothers had a real nasty crash at one time. The passenger was killed and he had a bad hip injury. Think about maternal behaviors. Think about a mother that distracts a predator. The predator might kill her, but she'll do it to protect her brood. So that doesn't hold true. So what that does, and this is the question I can't answer. I wasn't able to find enough information. In fact, I was hardly able to find any. This is the question I can't answer. How deep does that division go between affect and homeostasis? I mean, how much does homeostasis contribute to the creation of affects? I mean, does it at all? I mean, does it most of the time? Certainly not all emotional behaviors restore homeostasis. So that's the question that's the outstanding question at the end. And I would love to hear what other people have to say about it, because I cannot answer it. Couldn't find anything that would enable me to answer it.
That's a fascinating read.
Yeah.
That's a fascinating read. You almost took us through your whole journey of your book.
One thing I will say about the book, in case anyone's interested in reading it, I'm not a gifted writer or anything, not at all. I don't write with much flair, but one thing I can do is I can make things clear. And if you read the book, I mean, a few people I know who don't know much about neuroscience have read it, and they understood it, because I explain everything. And I write I wrote it for myself. Anything I didn't understand, I just researched the hell out of it until I got it, or failed to get it, as I was just saying. So if anybody wants an understandable read, if you were looking for a beautifully written one, then I don't think I can help.
It's very Hegelian in a way, right? We have all these theses, and then you have the antithesis, and we're hoping maybe we can synthesize this all at the end of the day.
I don't know. Yeah, it's we'll see how it ends up. I would just like to see what people have to say about that issue of homeostasis and affect.
You took me in a different direction. I mean, I know we got to go here in a minute, but it's interesting because I got one direction that I was picking up for a second. It disappeared once you presented the clear argument between homeostasis and affect. I was thinking about Carol Dweck and motivation, and motivational theory, and McClellan, and see how that plays a role on the seeking system.
Well, you see, affects do motivate. That's affects do motivate.
So motivate is the result of the affect, then.
Yeah. I mean, emotional arousal, if it didn't lead to behavior, I mean, what's the point of it? Yeah. Behavior determines survival. So, but if you look at
this argument.
the funny thing is, if you look, I mean, Damasio talks about this himself, and I researched it quite a bit. If you look at bacteria, you look at colonies of bacteria, some of the bacteria will sacrifice their well-being. In other words, they'll expend energy to make food that the whole colony eats, consumes, whatever bacteria do. It will help other and sometimes they die because the other bacteria form spores to which they're not admitted. Some bacteria have basically commit suicide. I won't bother you with the details of how that happens. But if you even look down to bacteria, you see any number of organisms that do not, that behave in ways that do not support their own homeostatic needs, that oppose them.
Oh, wow.
That's there. That's there in every single aspect of life.
Well, if I bring anybody back on with homeostasis, I'll ask them that question for you.
Yeah, please do. Please do.
Ms. Biven, it's been a fascinating discussion. Thank you so much for being here.
Thanks for having me. I've enjoyed it.
Thank you very much, everyone. Hey, by the way, if you want to support our podcast, make sure to share and subscribe. Hit that like button. That really helps. Thanks, everyone.